As the title firefighter suggests, one of the prime responsibilities of the fire service is to respond to and extinguish fires.
It is crucial that every firefighter be well versed in fire dynamics, or how the fire starts, spreads, and develops, to ensure that they understand what the fire is doing, what it is likely to do next, and to help them choose the best available tactical option to give a victim the best chance of survival and to safely and quickly extinguish the fire.
This DVD focuses on fire dynamics. First, we will define fire, and then we'll take an in-depth look at the fire tetrahedron. We'll discuss the three ways that heat is transferred: conduction, convection, and radiation. Next, we'll look at the compartment fire dynamics, or placing the fire in an enclosed space. Taking compartment fire dynamics one step further, we'll then look at fires in structures.
Lastly, we'll use that knowledge to illustrate how to break the fire tetrahedron during real-world fire situations and how to look for signs of a ventilation-controlled fire.
First, let's define fire. Fire is a gas phase exothermic chemical reaction. The two main points here is that it's exothermic, which means it gives off energy in the form of heat and light. The second point is that it is a gas phase reaction. Solids and liquids don't burn. The material needs to be in a gaseous state in order to mix with oxygen, which is also in a gaseous state. It needs to be in the presence of heat in order to get the chemical reaction going. The fire tetrahedron is a useful tool to understand fire and to describe what is needed to create a fire. There are 4 components to the fire tetrahedron. There are 3 components that represent fuel, oxygen, and heat. The 4th component represents the chemical reaction that occurs when fire is burning. By creating an environment that has a combustible fuel in a gaseous state, a proper ratio of oxygen, and enough heat to start and continue the chemical reaction, fire will result. Conversely, by eliminating any one of these components or affecting their ratios so that they are out of the accepted range, the fire will struggle and eventually it will go out.
The leg of the fire tetrahedron that firefighters traditionally attack is the heat leg. With water, we cool the fire to a point where combustion doesn't occur.
Let's take a closer look at the fuel component of the fire tetrahedron. For the most part, fuels that firefighters deal with are organic. In other words, they contain carbon. There are also inorganic fuels such as combustible metals like magnesium, but today we'll be focusing on the organic-based fuels. Fuel comes in many forms. It can be gaseous, such as the methane or natural gas that heats many of our homes. It can be a liquid, such as gasoline or liquid propane, or it can be a solid, such as wood, cardboard, or plastic. As we mentioned, this fuel must be in a gaseous state in order to mix with oxygen and heat, thus allowing it to ignite. To illustrate this, let's look at a candle. If we take a candle and blow it out, we'll see the fuel gases rising up from the candle in the form of smoke. When we take a flame and place it near the smoke ignites and the flame travels back along the smoke to the wick. It is the gases that are actually burning. We can use the same candle setup to visualize the fuel that is in the gas or the smoke that is rising from the candle wick. Take a cold spoon or piece of metal and place it over the flame. The cold object slows down the particles in the flame and deposits them on the metal.
This black deposit on the spoon is carbon, the same combustible carbon that is found on the fire ground.
The fire ground is made up of many different types of materials, from wood to plastics. Every material burns differently. When you look at different types of materials, such as burning wood or burning polystyrene foam, you can immediately see when they're burning that the amount of visible soot is very different. The wood burns clean. There isn't a lot of visible smoke, while the polystyrene has tremendous amounts of visible soot. You can tell right away that these two types of fuels are very different. The polystyrene foam is going to generate a lot more excess fuel.
Remember the candle. The smoke is the fuel that ignites. The cup is producing a lot more of that soot and smoke, and thus is creating a lot more fuel than the wood.